This video here is discussing Lesson 11 in Module 3 for the grade 7-8 in Eureka Math. First question here, talking about showing figures are congruent. Well, remember, congruent means exactly the same. Okay, so same, okay, think same size, same shape. Everything is exactly the same in both figures. Okay. If I'm looking at both of these two tables, would you say these are identical? Just by looking at these, we would say, oh, they're not identical because this one looks longer and skinnier, and this one looks wider and shorter. However, if you use, I got a sticky note here, if I measure, okay, you can see there with those marks, if I go through and I do the same and I match that up, you can see that they have the same length. This table just seems to be turned. Well, we've got one of them. Let's check the other one. So if I check mark here, and I check that, it matches up exactly. So this right here is just what we would refer to as a visual trick. These are actually the same tabletops. These tabletops are identical. Okay, and you can check that by, getting a piece of paper and marking where they are. You can check their measurements if they are given to you. Okay, but don't just always say, "Oh, hey, yeah, they don't look the same," because in this case, this is one instance where they are identical. They just look different. Okay, how they're presented. Questions 2 through 7 are going to talk about how we would map one figure onto the other. Much like in the previous lesson when we were describing the sequence of rigid motions, that's a continuation of that here to determine, to map onto the congruent figure. Okay? This is telling me that these are the same. Okay? That would mean that A matches up with D, B and B, C and C. Okay? So how could we get a sequence of rigid motions? If I'm looking at this one, there's one that immediately comes to mind. Okay? And that would be a reflection. In this case, if I just reflect, okay, if I have a reflection across BC, okay, that maps triangle ABC onto triangle DBC. Okay, so if I just use this as my line of reflection, I just flip it over and it matches perfectly. Okay. In this case, we don't have a sequence, we just have one motion that we need to complete. Number 3 is saying ABC is congruent to DBE. Some of you might look at this and think, oh, a reflection, and just reflect it over this point here. Well, if we do that, if it would match up, that would map A to E. And if you look up here in your congruent sentence, A does not match up with E. A corresponds or matches with D. So how would we get A to match up with D? Well, this would be a case where we would have to just turn our triangle. Okay? A rotation of 180 degrees maps triangle ABC to triangle DBE. Okay, turn this around. Okay, we spin it. C is going to go to E, A is going to go to D, and B will match up with B again. Next question we have, number 4. It says ABC is congruent to DBE. Okay. This is one where we might have to have multiple rigid motions. You could maybe say, well, if we reflect it, well, there is no line here to reflect. Okay? What I would notice here is that I have, if I could look at E to B and B to C, that makes an L, which makes a right angle. Okay? Not officially, but using some just tricks and knowledge of things I know, I see an L. Okay? And to me, L's mean 90 degrees. Well, if I rotate 90 degrees, clockwise, a 90-degree clockwise rotation around point B, that's going to bring this triangle down here. Well, then after we rotate that, so followed by a reflection across BE, that will map triangle ABC onto triangle DBE. So I'm going to rotate this down to where it matches up. Okay, again, because this is an L, this tells me that if I rotate it 90 degrees, this is just going to come straight down here. Okay, so then I would have, this is a very rough drawing here. Okay. I would have my A, B, C, E here, and then I would reflect over this line to map that on there. So we're going to rotate 90 degrees clockwise, and then we're going to reflect it across BE. If you look at the next set of questions, 5, 6, and 7, they are not touching. Well, actually that 6 is. Set 5, 5 is not. These markings, indicate which angles are the corresponding angles. You can also look at that here, T to G, H to U, E to M. So we've got triangle THE and triangle GUM that we're trying to map onto each other. I'm going to look at trying to map my points together. If I use a translation from T to G, that's going to give my triangle So a translation along TG will match up points T and G. Okay. Then, so we would have again, if we could draw this over here, we would have T, H, and E. Well, we don't want to rotate it 90 degrees because it would only match up to here. So if we did rotate that 90 degrees, we wouldn't be finished. Followed by a 90-degree, since we're going backwards, we would say counterclockwise rotation around point G. That would match, that would have these lines here. Well, that would match up these two angles to these two angles. But we still have to match it up because they're just side by side. We would then need to reflect across GM to maps triangle THE onto triangle GUM. So when we translate it, there's our first one. When we rotate it, we have 1, 2, 3, 1, 1, 2. Then we would need to reflect it over this line to match these up. Again, very quick, very crude drawing here. Not exact, but we have the translation. We can rotate it to where we have the lines match up, and then we reflect it over the line. Number 6. What I'm going to do here is I'm going to again try to match up my points that, so if I look here, I'm looking and saying, oh, I just need to slide this down. Well, I could translate from T to G. So we would say a translation along TG. So that's going to map this up. That's going to slide everything down. Think of it like this. There's the triangle again. Just a quick drawing, and then we would need to reflect over GB, followed by a reflection over GB maps triangle RAT onto triangle BUG. Looking at the next one, question number 7. Pi and dot. Well, again, I think we've got one of these ones here that we need a translation. So if we translate from P to D, it's kind of like we have right there. And then we would need to, again, reflect Okay. Reflect over that line there. Okay. So, if we have a translation along PD followed by a reflection over DO, that maps triangle, or not full figure, not maps PIE onto figure DOT. So for these next few figures, 8, 9, 10, and 11, we're going to figure out if they are congruent or not. Okay? If they are, we're going to describe a sequence of rigid motions to explain how they are, and if not, we're going to tell how we know. Now, this one here, okay, they appear to me be same size. Okay, if we measured, okay, if we took a piece of paper and measured, okay, we would, without a doubt, determine that they are, in fact, congruent. Okay, so we would say congruent. Okay, well, how would we figure out how they are congruent? Or how could we map them onto each other? Well, I know that G and F are the ones that match up, so I would have a translation to map these onto each other. Okay, a translation along GF. Okay. Well, now that that's here, there's my figure. Okay, I'm going to need to rotate this, followed by and since I'm going forward, I'm going to say 90-degree clockwise rotation around point F. Okay, that would map this on here, like so. Then we would just need that reflection, followed by a reflection across, start at the right point there, across HF. Okay, we would say maps figure GOLD onto figure FISH. Looking at question 9, okay, I'm not sure just by looking at these exactly, how we can tell. However, there is one thing that we can do. We can figure out, okay, I'm just going to use this one, CO. We can make a triangle to determine this measurement. We have to use our Pythagorean theorem. We've got 1, 2, a side of 3. We got 1, 2, 3, 4. And we know that 9 plus 16 equals 25. Take your square root, and we figure out that this is 5 units. Well, the side that matches with CO is HE. Well, if we do our triangle here, I've got 1, 2, 3, 4. Okay, so I have 4 squared, 1, 2, 3, 4 plus 4 squared equals c squared. Okay, even without doing any work, I notice that I have different sides of my triangles, okay, which is going to be a reason enough to say these are not congruent. So anytime that you're looking at figures on a graph, you can look and say, hey, do they have the same measurements somewhere? Okay. We're going to skip to 11 real quick just to show this here. I have 1, 2, 3 for BM. Well, BM matches up with RI. 1, 2, 3. So these would be congruent. Now, how would we get these to map onto each other? Okay. I think if we had a rotation of 180 degrees, that would match these onto each other. Okay. On this last figure, okay, which is actually 10, we went backwards to 10. Okay, if you're looking and checking, okay, if I translated along DH and then rotated 90 degrees along point H, okay, these would not match up because we have different measurements. Okay, even again, using the sticky note, I got almost the whole sticky note, right? If I measured that up here and lined that up, definitely not the same size. Okay, so these would not be congruent.